All right, guys, this one is probably going to be one of our easier lectures to date. It is on integers, and so let's jump in. Section 5.1. So, integers, we're going to talk about what integers are and how to think about them on a number line and sets. The set of integers is denoted by I, and basically you have the negative whole numbers, 0, positive whole numbers. So -4 is the opposite of +4, 3 is the opposite of -3. For each of the following, find the opposite of x. So you're going to just switch the sign. So if you had 3, the opposite would be -3, -5, the opposite would be 5. And the opposite of 0 is just 0. Absolute value denoted by these bars here. This means the absolute value of 4, and it technically means the distance from 0. Or you can just think about it as making everything positive, okay? So the absolute value of -4 is 4. The absolute value of 4 is also 4. So the absolute value always returns a positive number. For any integer x, the absolute value of x is equal to x if x is greater than 0. So some define it like this. Absolute value of x is equal to this piecewise function here. It's x if x is greater than or equal to 0, and negative x if x is less than 0. And if you wanted to look at it on a graph, it would look like this. So if I'm at 1, it returns 1, right? If you're at -1, it also returns 1. So it makes this V shape here. Again, it's always positive or 0. So find absolute value, basically just make sure you make it positive. But there is something to note here. So this negative outside the absolute value is it's like -1 times the absolute value of -3. Well, absolute value of -3 is 3, and then you have this -1 here, so now it's going to be -3. So, oh, excuse me. This is kind of brain weird. I don't like how it is. It could be like x minus 5 equals 1. So in this case, you have either x minus 5 equals 1, or you have x minus 5 equals -1, right? Because this whole thing here could be -1 because absolute value of -1 is also 1. So if I solve this one, I add the 5 over, so then I get x equals 6. This one, if I add the 5 over, I get x equals 4. So these both would be a true statement. If you put in 6 here, 6 minus 5 is 1. Put in 4, 4 minus 5 is -1, but the absolute value of that is 1. This is talking about chip model here. So just kind of balancing things out. If I have 2 positives, that's +2. This would be +2 as well because the negative and the positive cancel. This would be a -2 because the negative and positive cancel. Number line model, which is here. So the charged field model, similar to the chip model, but it's just using pluses and minuses. So basically, I'm so sorry, the plus and the minus cancel each other out. So you're left with -2 here. This is the word problem. The temperature was -4 and now it rose to 10. So what's the new temperature? So it rose 10 degrees, sorry, not 210. So you add 10 to -4. If I add 10 to -4, the first 4 on this side is 0, right? And so then this part is actually going to give you that +6. But when you read this, you can also switch it around because remember addition is associative. So you can write it as 10 minus 4, and that is 6. Here's facts. So it's just showing you adding 4 plus 3 plus 2 plus 1, but then if we're taking the negative and adding it, it's really like you're subtracting, okay? M is an integer, then 0 plus m is equal to m. But then if they're both greater than 0, then we're going to add. If if they're both negative, then it's like you're adding them together with a negative. But if they're different signs, then you subtract. and whichever one is more negative wins out. That's what all these things are saying. Okay. This is talking about absolute value. Integer addition has all the properties of whole number addition. So it's unique, has commutative property where you can switch them around, or associative property, which means the order does not matter. The identity property is 0 because when you add 0 to a number, it stays the same. The additive inverse is the opposite number. So -3 and 3, 5 and -5, because that returns 0. So if we're going to apply some of these rules, negative A is equal to A. Addition property, negative A plus negative B is equal to negative A plus B. And just to explain what that means with some numbers, like if I have -3 plus -2, they're saying I can think about it as just adding a 3 and a 2, but they're both negative. So the answer is -5. And I often picture the number line in my mind, right? Like I'm at -2 and I'm going to go more negative, go left 3. So 1, 2, 3. So where am I going to be? I'm going to be at -5 because I kind of think about it fractionally. So this negative means you're moving to the left, whereas a positive means you're moving to the right. So the additive inverse would return 0. So negative, parentheses 3 plus x, we just need to add 3 plus x. And essentially you're turning the whole thing, you're flipping the sign. So if it's a -4, then it'd be -a plus 4. This is -3 plus a negative x. So if I'm going to flip both sides, they're both going to become positive. Is it the chip model again? Number line model. Okay, it's showing how to subtract integers. I trust you know how to do 3 minus 2, 3 minus 3, 3 minus 5. Again, you can think about the number line, which is what I often do. Or you just know if they have different signs, like this is a positive, and this is a negative. And that means you're going to subtract. It doesn't matter which one is positive and which one is negative. You're going to subtract the two numbers. So what's 5 minus 3? 2. Now you ask yourself, which one wins? Which one is bigger? Is this more negative or more positive? Well, the guy that wins is the more negative number. So that's why it's a -2. Or you can visualize it here. I'm at 3, and you're going to go left 5. Okay, so we're going to go left 5. 1, 2, 3, 4, 5. Where did I end up? At -2. So you can also visualize a number line. So what I usually do is if they are opposite signs, you subtract. Whichever one is most negative wins. This is just it's a unique number. 3 minus 10 is, take the difference, that'd be 7. It's going to be -7 because which one is bigger? That's the -10. If they're the same sign, these are the same signs, you're going to add. So it's like a -2 plus a -10. So they're both negative. So you're going to add them together, you get -12. Okay, so same signs, like if I had 10 plus 2, that'd be 12. If I have -10 minus 2, that is -12 because they have the same signs. But if they have different signs, you're going to take the difference. So what's the difference between 10 and 2? 8. This one's more negative, so this becomes -8. The difference between 10 and 2 is 8, but this one is more positive, so the answer is +8. So that's just adding and subtracting integers. They're just saying that a minus b is the same as a plus -b. So there's rewriting all these. So like 2 minus 8 is the same as 2 plus -8. That's, again, take the difference, which would be 6. This is more negative, so negative. Negative is a positive, so you're actually adding these. This is a negative, so it's actually positive. So now I have a 12 and a 5, but with different signs. So that means you're going to subtract these two, which gives you 7. This one's more negative, so you get -7. These are both negative, so it's like plus a -5. They're both negative, so you add, and then negative result. This is just showing the distribution, right? I go bring that negative into the b, into this -c. So then it becomes -b plus c. Here you subtract b and subtract c. Again, when we're going to distribute, it's really important you take this negative to both. So 2 minus 5 minus a negative x, makes it a plus x. So now I have 2 and 5 have opposite signs. So you're going to subtract them. The difference would be 3, right? But it's going to be a negative 3. Why? Because the 5 is the more negative. It's the number, whatever larger number is, you take the sign of the larger number. And I can switch that around to be x minus 3 if I want. This is 5. Distribute this negative, so minus x minus a negative 3 is plus 3. Now I notice this 5 is a positive. This 3 is a positive, so I have negative x plus 8, or 8 minus x. Then distribute. So negative x minus a negative is plus y minus y, and these guys would add to 0. So you just get negative x for that problem. The expression such as 3 minus 15 minus 8 is ambiguous unless we know or perform the subtractions. So we're just going to agree that you go in order, okay? So subtractions are going to be taken as from left to right unless they have parentheses around them. So when I see 2 minus 5 minus 5, I am going to do 2 minus 5 first, which is negative 3, and then I'm going to subtract 5, which is negative 8, because these are the same sign, so I 3 minus 7 is negative 4 plus 3. These are different signs, so I subtract them to give me 1, but now the big one is negative, so it's negative. Now this one I actually need to distribute here, or I can do this first and say that that is 4, and 3 minus 4 is negative 1. Okay, so that's all for the integers. Attempt your assignment, and as always, please reach out to me if you are stuck or you need help.